writing equations of linear graphs. So now that we know all about how to solve linear equations, let's graph them on an XY coordinate plane. So to start, let's look at just how we can write equations that represent this line here, which is a graph. So there's two things that we want to look at in a line graph, which is the graph of a linear equation. The first is called slope, and we represent that with the variable m. And the second thing is called y-intercept, and that is represented with the variable b. So to show you what these things are, let's just start doing them with this line right here. So first, slope. M equals. Slope is how the y coordinate of this graph changes in relationship to the x coordinate. So what that means is it's just a ratio, and the ratio is change in y compared to change in x. So it's a fraction. This little triangle is called delta. It just means the change. So this would be read as delta y over delta x. And this is what slope is. So in this line, the slope is, well, let's take a look. Here we see that every time the y goes up by 2, the x goes up by 1. Y goes up by 2, x goes up by 1. Just like that. And since this is a straight line, the slope is the same throughout the entire line. So when y goes up by 2, x goes up by 1. So that means that our slope, just simplify this fraction here, the slope is 2. The slope of this line is 2, because y goes up by 2 every time x goes up by 1. Now, the y-intercept. The y-intercept is very simple. It's just the y-coordinate at the point where the line crosses this y-axis here. So we can see from this graph that it's going to be right there. In fact, let's just mark that in. It's going to be right there. So that is a y-coordinate of 3. So the y-intercept is 3. So now, how do we put all this into an equation? Well, here is the formula for the equation of a line. Y equals m times x plus b. So now, let's just substitute in our m and b values. Y equals 2 times x plus 3. And there we go. That is the equation of this line. So what this means is that if you pick any point for y, it's going to be equal to 2 times the x coordinate of that point plus 3. And this equation is true for any point on this line. Okay, let's look at some more graphs now. We have plenty of examples here. Okay, over here, first let's look at slope. So, with slope, since it's the same for the entire line, we can pick any 2 points on the line. So, to just show you what that might look like, let's pick 2 points that are very far away. Let's pick this point here and this point here. So now we're looking at the change in y over the change in x. So change in y, let's take a look. It goes up 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes up 9. and the x goes up by 1, 2, 3. So the slope of this line is going to be 3. Now that would have been true if we had picked points that were closer together, which is usually easier. So let's say we pick this point here and that point there. Same thing, we see that y goes up by 3, x goes up by 1, which would still be a slope of 3 over 1, which is 3. So you can pick any 2 points on the line to determine slope. And the y-intercept, that's going to be this point right here, so that's going to be a y-coordinate of 4. So the y-intercept is 4, and the equation y equals mx plus b will be y equals 3x plus 4. Okay, so hopefully you're getting the idea of how to do this by now. If we look at this one right here, this one has an interesting slope, because if you look at it, x goes up by 1, y goes up by 1, x goes up by 1, y goes up by 1. It's 1 over 1, which is 1. The y-intercept right here, that's going to be at -2. The y-coordinate is -2, where we cross the y-axis. So now, y equals mx plus b. Since m is just 1, remember when we have a coefficient of 1 in front of a variable, we just don't even bother writing it. So we'll just say y equals x minus 2, because x is the same as 1x. There was almost like an invisible 1 in front of here. Okay. The slope of this line. We see that y goes up by 1, where x goes up by 2. Y goes up by 1, x goes up by 2. So change in y is 1, change in x is 2. That's our slope, 1/2. So we do have a fraction as a slope. The y-intercept is going to be -5. So the equation here will be y equals 1/2 x minus 5. Since b is -5, we write -5. Alright, now here things change a bit because we can see that the line is going in the other direction. And so here's how that works with slope. Here, let's draw on some points so we can understand this. Okay. Let's say we're starting here. Let's draw on this point here. And then let's pick that point right there. Okay, so now we see that when y goes up by 4, x changes by -1, because remember when we go to the left, the numbers get more negative. So y goes up by 4, x goes up by -1. So it's 4 over -1. Now, of course, we could also go the other direction. I don't know if I've mentioned this yet, but slope, of course, is just a ratio, so you can calculate it either direction. So we could also say that we're going down by 4, which is a -4 change in y, and then a +1 change in x. So either way of writing it, and from either of these fractions, 4 over -1 or -4 over 1, either way it'll come out to -4. So we have a negative slope. When the line is in this diagonal direction, the slope is negative. Y-intercept, let's see, let's just count down here. It's going to be right at that point there. That's -8. So y equals negative 4x minus 8. Okay, lots more graphs. Here we go. Alright, now we're going to start throwing in some more weird things. Okay, so the slope of this one. Let's see, where can we start? Looks like we have a point right there. And we have another point right here. Okay. So, once again, we can tell by the direction of this line that we're going to have a negative slope. So, we go up by 4, so a positive 4 change in y, and left by 3, so a negative 3 change in x. So the slope is negative 4 over 3. And the y-intercept here is going to be 7. So y equals negative 4 over 3x plus 7. Okay. Once again, a negative slope here. Now here we're starting right at 0, 0. And that's by the way is called the origin. 0, 0 is the origin. So we go up by 7 to get up here, and then left by negative 4. So we go up by 7, whoops, up by 7, positive 7 change in y, left by negative 4, so left by 4, so that's a negative 4 change in x. So this is negative 7 over 4. Now the y-intercept. What is the y-intercept? Well, what's the y-coordinate where we cross the y-axis? At this point right here, y is 0. So the y-intercept is 0. So when we write our equation, y equals negative 7 over 4x. Are we going to bother putting in plus 0? No, we're not, because plus 0 doesn't change anything. Just like if you have a 1 as a slope, if you have 0 for a y-intercept, plus 0 doesn't affect the equation in any way, so we're just going to leave that out. And so this is just y equals negative 7 over 4 times x. Okay. Here, let's see. Let's see if we can do this without drawing in points. You can see here the pattern. Up 3, right 2. Up 3, right 2. So, up 3, right 2. There's our slope. We're back to a positive slope. The y-intercept. Now here's the thing with the y-intercept. You can see it's like kind of in between 0 and 1, but it's kind of hard to tell exactly where it is. Since it's between 0 and 1, that means we're going to have a fraction. So how do we tell what that fraction is? Well, let's look at it this way. At this point right here where x equals 1, y is 2. So we'll put it right here. Where x equals negative 1 right here, y is negative 1. So now, since we have x equals 1, x equals negative 1, well, this y-axis where x equals 0 is right in between these 2 points. So the x value, 0, is right in between 1 and negative 1, which means the y value will also be in between. So here this is y is 2, this is y is negative 1. So what's in between 2 and negative 1? Well, it's going to be right here, which is 1/2. So right in between these 2 points, y equals 2 or y equals -1, y equals 1/2 on this y-axis. So now this is going to be y equals 3 over 2x plus 1/2. Okay, this one looks a little different. It is going in this diagonal direction this way, the opposite direction, which means we're going to be back to a negative slope, just so you know, you can tell that right away. Okay. Yeah, it's a little hard to see from this drawing, but I'll just tell you the points were supposed to be there and there. Those are the exact points where it crosses on a grid line. So we can use those for slope there. So y changes by 1, x changes by -6. 1 over -6 is -1/6. So that's our slope. Y-intercept. Okay. Now how do you do y-intercept for this one? Once again, we can see it's going to be a fraction. Well, let's just look at another point right there. Okay, so we're going to do the same thing we did here, except this time it's a little trickier because we don't have 2 points on even grid lines that are halfway or equally apart from what we're looking at. So if y is -2 here and y is -1 here, well, let's think about this. We're changing by a total of 6x. So to get from here to here, we're going essentially 1/6 of the way to get from here to here. So that means the y is also going to change by 1/6. So if to get from here to here, y changes from -2 to -1. Then to get from here to here, y is just only going to change by 1/6 of a point instead of 1 point. So 1/6 of 1 is going to be 1/6. So 1/6 greater than y equals -2 will be -1 5/6, which is -11/6. So when we write this, it'll be y equals -1/6 x minus 11/6. That one was a tricky one. It's pretty rare you'll get a weird fraction for a y-intercept like that, but that is how you calculate that. You pick 2 points and then you see that this is 1/6 of the way to there, therefore the change in y is 1/6 of what it is to get from there to there. Okay, that was a tough one. Alright, now for our final few graphs, let's throw in some more interesting looking things. Now this is what's called a horizontal line because it's perfectly horizontal, just going left to right in both directions, never changing in its y value. Its y value is always going to be what? It's always going to be 3. Y is always 3. Y equals 3. And here's what's cool. You're done. That is the equation of this line right there. That's it. Y equals 3. Since y is always 3, the equation is y equals 3. Something similar for this one. This is a vertical line, so it's perfectly straight up and down. And here we can see that y could be anything along this line, but what is x? X is always going to be -1, -2, -2.5 right here, which is -5/2. So since x is always -5/2, x equals -5/2. And you're done. The only thing a little confusing here is that for a horizontal line, you have y equals a number, and for a vertical line, you have x equals a number. It seems a little bit backwards. But if you think about it, it makes sense because you just look at whatever is always staying the same. In a vertical line, the x is always the same. In a horizontal line, the y value is always the same. Okay, and now for the very last graph, let's throw in something a little strange. We have this 5 here. This 5 is right along this grid line right here. And what that means is that's an interval. So what we're saying is we're counting by 5s here. And you'll see why we did this was put here after we come up with the equation. Now it doesn't affect the slope at all, because the slope is the same along the entire line. The slope is still going to be, let's take a look. If we start right here at our y-intercept, and we have a point right there, we're going up 7 and left 2. So positive 7 change in y, negative 2 change in x. That's negative 7 over 2. The y-intercept, this is where the interval matters. Since we're counting by 5s, here's how we're going to come up with the y-intercept. We're actually going to, each little grid line counts as 5. So negative 5, negative 10, negative 15, negative 20, negative 25. So the equation is going to be y equals negative 7 over 2x minus 25. And the reason we had that interval thing there was because if we didn't put that there, then negative 25 on this y-axis would be way off the graph. There would be no way to show that. And technically you can have a linear graph not showing where the line crosses the y-axis, but most of the time you want to show that, so you need to use an interval. But anyway, that's when we actually get to how to graph these things. So we did a lot of different types of linear graphs in this video. Here we have intervals, horizontal and vertical lines, weird fractional y-intercepts, lots of fractional slopes, positive and negative. So we really covered everything, pretty much everything there is to know about writing equations for linear graphs. So now, in the next few videos, we're going to get into how to actually graph the line given an equation in the y equals mx plus b form. So go ahead and watch that.